HVAC 360 is brought to you today by watermelons. Sliced, diced, or in a ball, watermelons are a great summer treat to liven up any cookout. Put down those cookies. Get away from that creepy ice cream truck. We're all natural and grown by friendly farm folk. Cool down today with watermelons. Please spit responsibly. Hey, what's up? Welcome back. This is episode number 90. Matt Nelson here, your host for HVAC 360, helping you go further and faster in the field of HVAC. Listen up, and you're going to hear stories, industry experts, and we're going to fill up your HVAC knowledge tank to full every week. So those of you who are new here, definitely go and subscribe. There's going to be some extra stuff this week as far as where to catch some additional learning, where to get some new information. So go sign up on my list at HVAC360.com to get that, and you'll get access to that bonus material that I send out on a weekly basis. So what's up for this week? This week, I wanted to share a couple of takeaways that I got from my Trane chiller workshop. That was the manufacturer Trane, not the choo-choo. But they do this great job of coming out to the local areas, and there might be something around where you live. But they do put on these events, and Trane really has it going on. They have a lot of information. They give you a workbook, and they covered a lot of material at a pretty fast pace during this workshop. And, you know, some of it was good, some of it was brand new to me, and some of it was just stuff that, you know, didn't quite interest me, but that's, you know, it's not their fault. It's always, you know, knowledge is something that it could be new to you, but it's not new to me. But I just want to be able to share a couple of takeaways that I got from that session. And we'll hear that after a brief word from our sponsor. All right, so what did I learn? A couple of these things that I'll point out, I'm going to cover in a little bit of detail. Others, I'm just going to leave at a high level. That's just where it's at, and it's just kind of making you aware of some things that I was made aware of, and I'm just going to share those things. So here's my 6 things to share from the chiller workshop. All right, the bypass line sizing. This was interesting. It was to size a bypass, and this again is for a chiller plant. Size the bypass according to the largest chiller and not the manifold size. A lot of times, people get into the habit of sizing a pipe just because either, you know, like I'm gonna make this pipe the same size as a discharge on a pump, or, you know, it's just because, and they don't really think about it. But the bypass, making the bypass smaller in essence, so instead of having the large manifold type size, reduce it down to the largest chiller. So that's as big as it needs to be, because you're not going to bypass any more water than you would through the largest chiller. That's the point there. Number 2, increasing the delta T across the chilled water system. Now, this is one thing that is kind of a little bit newer to me. I mean, I'm not in the design day in, day out, but I do start to see this more and more, and a couple of these points are hitting right on this. So what you do is you have your chiller, actually, when you increase the delta T, your chiller is part of that. So you're going to end up increasing the chiller energy usage, but what it does is it reduces the pump energy. So in essence, when you combine those two, there's a net energy savings through the system. Obviously, your chiller output is going to be at that, you know, at the max of like 57 degrees, just because you want to have that, you know, condensing coil temperature, and, you know, that's where it's maxed out at, or it's going to come back at 57 degrees rather, and you're going to shove it out there at, say, a 42 degrees. You know, then you're playing with that fine distance between where water freezes and where your discharge of your chiller is going to be at. And kind of in concert with that, ASHRAE 90.1 2016 is now stating that your coils out in the system shall be, and that's pretty, obviously it's written in code language, so it shall be at a minimum of 15 degrees Fahrenheit or higher. So they want these larger delta T's. So that's saving energy. All right. Chilled water flows. I got reintroduced, anybody who's gone through school knows about the Reynolds number. I'm probably going to do a little bit more about that, maybe in a video form or a little bit later, but I'm doing a little bit of research now on the Reynolds number and where that comes from and where those ideas are. But the Reynolds number basically tells you in a pipe if you have laminar flow, which is kind of like just think of smooth flow, or you have turbulent flow. So there's a lot of churn. And obviously when you want heat transfer, you want more churn. So that's a number that you kind of tells you exactly if you're in the right area for good heat transfer. And they pointed out that chillers really need to be selected, obviously, in a turbulent flow. So they're looking at the higher Reynolds number, and they're going to be looking at 5 to 7 feet per second, looking in that range. That's going to be the sweet spot. So if you get much higher, if you get to like 11 or 12 feet per second, not only is that someplace where you wouldn't select a normal pipe, but you don't want to select a chiller there because you're going to get some erosion in the pipe, and you want to be able to, obviously a super expensive piece of equipment, you want to make that last as long as possible. Even though they've in the same session, they talked about over pumping the chiller. So obviously the chillers really don't like, low flow conditions. You can't really play with the minimum flow of a chiller too much. It's going to knock off and shut down, and I see that all the time. So there's a minimum flow, and there's also a maximum flow, and obviously you want to play with that. Select it in the middle so you have a little bit more room to play with and overpumping, possibly overpumping a chiller. They went in to talk about buffer tanks, and I guess buffer tanks, I've seen them on a number of applications. I haven't really designed buffer tanks, but I was always curious about I know you need a buffer tank when your overall length of your system isn't that great, when it's really short, when you have a chiller and a air handler right next to each other, you typically need a buffer tank. So the buffer tank just adds volume to the system, but there's this thing that they refer to as minimum loop time. So you take the minimum loop time times the GPM of the system, and that gives you kind of a required volume. So once you know your required volume, then you can kind of back out the volume of your system, and if you have to add a buffer tank based on that. Other things you can do to kind of reduce or eliminate the buffer tank size, you could have larger pipes. So instead of having a buffer tank sitting there, you could actually increase the pipe size and have your buffer tank essentially be the system. So you can increase the pipe size, and also, I guess in a theme, you can have the higher delta T's. So when you have the higher delta T's, your flow goes down, your flow rate goes down because you don't need as much flow because you have the higher delta T, and that shrinks everything. All right, and the last thing that I wanted to talk about, and this was kind of new. I've never seen it in application before, or I've never actually seen it being installed before, is serial chillers. Serial chillers, both kind of in a piping form where you have two chillers, and they're just kind of back to back. They make those, or you could design it like that, or they actually make a kind of like a closed coupled chiller, and I guess Trane makes those units. So that was something that I've never heard about before, but it's the serial chiller. So that way you kind of enter at one water temperature, and then you can drop it back in 2 stages across those 2 chillers. So that was an interesting way to kind of, depending on what your flow rate is through the system, that way you could get a higher delta T through the system. So that might be something that, take a look at. It might fit your applications. It might be something that you need to take a look at. If you didn't know about serial chillers, that's kind of why I'm mentioning it, rather than kind of, going into a lot of detail on where, when they're used. So, all right. Those are my 6 takeaways. Thanks for Trane for schooling me up this past week. The best part for you, obviously, you couldn't be there, but they do have available on demand these training sessions. So you can watch some videos, sign up for them, watch the videos, and learn. And they have, I don't know, probably like 6 to 8 of these things online. So, and they also have these engineering newsletters. If you didn't know about the engineering newsletters, those are also some more information that you can access. All right, for that and more information, you can go to my show notes at hvac360.com/90 for the 90th episode. And that's a wrap for this week. Thank you for your time. I appreciate you listening each and every week. You're the top 3%, as I make mention to a bunch of times. You're the active learners in this industry, and you're just the best. So thank you for listening. If you know somebody who's looking at doing chiller design, because it's not one of those things that you do every day, it's on a project-by-project basis, but you may want to share this episode with them just to kind of rattle their cage a little bit, let them learn, and maybe it kind of stimulates them to ask questions that they need to make a really great design. So share that with them. You become their hero. You become my hero. And as I mentioned at the top of the show, if you're not on my list already, go to hvac360.com, get on that list. And if you want to do more, I definitely appreciate and be deeply honored if you'd leave me a rating on iTunes. That would help out immensely and get more people to know about HVAC 360. So that's a wrap for this week. I'm Matt Nelson, helping you go further, faster in the field of HVAC. And as always, know what you build and share what you know.